Hello everyone. The next electrophilic substitution reaction of phenol is Friedel-Crafts reaction. Very important for 12th JEE NEET because it's a name reaction. Let's start. For this Friedel-Crafts reaction, phenol must be treated with methyl chloride. This is methyl and this is chloride. Methyl chloride, IUPAC naming 1-chloromethane. 1-chloromethane. This is IUPAC naming. And methyl chloride is a common name. Methyl chloride. This is a common name. Now this reaction we have to perform in the presence of AlCl3 anhydrous AlCl3, and what we are going to generate, the mixture of these two products will be generated there. This you can call IUPAC naming. If I do, this is main functional group 1, 2. So second position covered by methyl as a side chain, 2-methyl phenol, and its common name we have already discussed. This compound cresol, it is orthocresol, common name. Similarly here numbering will start from here 1 2 3 4, 4-methyl phenol, fourth position, and this whole group as a phenol, and you can call it para-cresol, common name. Now this is Friedel-Crafts alkylation reaction. Up to 12th level, very easy to learn. Look how simple. You know, in phenol, benzene ring is a source of electrons. Here we have a benzene ring, it's a source of electron. Electrons are present on which position? Ortho and para positions. Many a time we have discussed. Out of this carbon and this is Cl, which is more electronegative. Cl is more electronegative, so Cl is carrying negative charge because electrons are toward Cl side, and this carbon part is carrying what charge? Positive charge. Means this part, hydrogen also have a very less electronegativity, carbon also have a very less electronegativity as compared to Cl, so this CS3 part will become positive. Positive part means electrophile. Electrophile need electrons. Where we have electrons? On ortho and para position. Just simply you need to put them on ortho and para position. Look, once ortho, some particles will join on ortho position and some will join on para position, and let me tell you what will be the side product. HCl will be the side product. How? Because here hydrogen will be there, which will be substituted by CS3, and hydrogen always will release out as H positive. This H positive will combine with Cl negative. Side product will be HCl. Now out of this ortho product and para product, which will be the major product? This will be the major product. Para product will be the major product. Percentage, if I talk, it can be generated 55 to 70%. And rest percentage will be of ortho there. Reason already we have discussed, because in para products the groups are far away from each other, so no repulsion problem. But in ortho the groups are very close, so repulsion problem will be there. That's why the compounds will be highly unstable. That's why they are in less amount. Up to 12th level we can learn this reaction like this. Now if I talk about the mechanism part, let's start the mechanism. Here we have a role of AlCl3. AlCl3 anhydrous AlCl3. It's a white color powder which is used in this reaction. Now in AlCl3, this aluminium, which is a central atom, have a vacant orbital, and with this vacant orbital it have a tendency to attack on pair of electrons. That's why this AlCl3 we call Lewis acid. What are Lewis acids? In which central atoms have a tendency to accept pair of electron because they contains vacant orbital. So we call them Lewis acid. So AlCl3 is working as a Lewis acid here. Now, it have a vacant orbital. So for electrons, we are using CH3Cl, methyl chloride. And in methyl chloride, you very well know that chlorine is more electronegative, so these electrons are toward chlorine side. So this chlorine is negatively charged particle here. Already chlorine is carrying 3 lone pairs over it. When chlorine makes single covalent bond, always 3 pair of electrons are there. And this carbon, if I open it, it is something like this. Actually, the carbon is bonded with Cl. So this carbon will carry a positive charge. So this is CH3Cl, and aluminium is looking for the electrons. So who can provide electrons to it? Obviously this chlorine. So what will happen? First step, this central aluminium atom will attack on chlorine for electron, and as it will attack for electrons, bond between carbon and chlorine will break, and obviously the electrons will completely shift toward chlorine because chlorine is more electronegative than carbon. And this pair of electron it will use to make bond with aluminium as a dative bond. So rest AlCl3 as it is. Between this aluminium and this chlorine, a dative bond will generate like this. These 2 electrons, 1 electron it will keep with itself and 1 electron it will pass toward aluminium. So this aluminium will carry now a negative charge. The vacant orbital of aluminium is satisfied by electrons and 1 electron is completely toward aluminium. So this aluminium will carry a complete negative charge. So this side species will generate there, or sometimes we also write it like this. In books it is written like this, AlCl4 -1. So this -1 is not on chlorine, it is on aluminium. Now, okay, this is generated. What about this carbon? This is the main point. Because carbon has lost its electrons, so don't you think this carbon with its 3 hydrogen will have a vacant orbital? It has lost 1 electron, so vacant orbital will generate on it, and because it has lost 1 electron completely, so positive charge will generate on it. What is this? This is methyl carbocation. Methyl carbocation. It's a methyl carbocation, or you can call it electrophile also, yes or no? Because this carbon have a shortage of electrons, so it need electrons. So every particle which need electron, we call them electrophile. So it's a electrophile. So this is a role of AlCl3. AlCl3 will attack on a methyl chloride and will create an electrophile there. Now who can provide electrons to this electrophile? Benzene ring. Benzene ring of the phenol is a high source of electrons. It will provide electrons to this electrophile. So the second step, please write this mechanism step by step by yourself. I am writing it randomly. Write by yourself. Do some work. Now, this is our phenol. We know which positions are best targeted by electrophiles, ortho and para. So first I am going to attack on ortho position. This is CH3 methyl. So with its vacant orbital, it will attack on this carbon for electron. For bond formation between this carbon and this carbon, 2 electrons are required. This carbon do not have electrons. So who will provide electrons to it? This carbon. How? By shifting pi electrons toward itself like this. With the help of these pi electrons, it will make bond with this carbon, a dative bond. So when it will make this bond, coordinate bond will generate between carbons, hydrogen as it is, rest molecule as it is, no change. Here also we have hydrogen, so please write by yourself. they are not required, that's why I'm not writing. Okay, this carbon has lost its electron, so on it vacant orbital will generate with a positive charge. Again, what we have, uranium ion or sigma complex, or you can call it simply a carbocation. A carbocation is generated there. Now, is it stable? Okay, first if I talk about charge, the positive charge of this carbon will finish, yes or no? Yes, because out of these two electrons, one electron will completely transfer to this carbon. Here it is, this is the electron that carbon got. So positive charge and the vacant orbital will finish, and one electron this carbon will keep toward itself here, no problem. Only the problem will be for this carbon, vacant orbital will generate here with a positive charge. Unstable it is. It is not a stable product, it is unstable, we know. How it will get stability? This carbon has made it carbocation, so this carbon will make it normal carbon. How? By breaking bond from its hydrogen and shifting these electrons here. In all electrophilic substitution reactions, we have done this mechanism. Carbocation is generated and it is stabilized by neighboring carbon by breaking bond with hydrogen. Like this, it will shift these electrons here, and this hydrogen will release out as H positive. Now first let me tell you what this H positive will do. You know, AlCl4 was generated with a negative charge here. Is it a stable? No, it's not stable. Out of aluminium and chlorine, chlorine is more electronegative, so every time electrons are more toward chlorine side. That's why this H positive is going to attack on chlorine. Finally, between aluminium and chlorine, bond will break like this, and electrons will completely transfer toward Cl again. These electrons it will use to make dative bond with this H positive, because this H positive contains vacant orbital. As you know, vacant orbital, lone pair, they will make bond with each other. So HCl will generate like this. The positive charge of hydrogen will finish because it got one electron. This electron is toward now hydrogen side. So its positive charge will finish, complete positive charge will finish, and one electron this Cl will carry with itself. HCl will be the side product like this. And what about aluminium? Because aluminium has lost electron again, so the negative charge of aluminium will finish, and again on it a vacant orbital will generate, rest Cl3 will remain there like this. So AlCl3 will be regenerated, and this AlCl3 will perform action with other particle of CH3Cl, and the same mechanism will be repeated. So AlCl3 is working as a catalyst here. So little bit AlCl3 can provide whole reaction again and again. Now come back to here. What will happen here? So this bond will be regenerated here. Here we have a bond, and this CH3 which is joined here, I am going to write it like this. H is already released out, so CH3 has substituted H. Rest molecule as it is, no change. OH is there, no problem, as it is everything. So what is this? This is orthocresol. But it will be a minor product. It will generate in less amount because OH and CH3 are very close. Repulsion problem. Due to repulsion, steric hindrance, molecule is highly unstable. Same mechanism you can make for para. Just attack it on a para position. Same shiftage of pi electron. Same generation of carbocation. Same release of H positive. H positive will attack on Cl negative. HCl will generate AlCl3. And at the place of ortho, we will have that time para-cresol like this. Same mechanism will be there. So try it by yourself. This is the whole mechanism we have for Freidel-Craft alkylation. Now one very important point. Okay, we have generated orthocresol and para-cresols with this process. But the problem is these compounds will be in very less amount. the amount of substituted products will be very less. What is the problem? Problem is here. Look. You know you are using aluminium chloride here, AlCl3. AlCl3 have a vacant orbital demanding for the electrons. Sometime what is happening? It is directly attacking on the oxygen of the phenol for the electrons. This is happening. What was the role of AlCl3? Actual role was this AlCl3 have to attack on Cl of methyl chloride, so we can generate CS3 positive carbocation, which will attack on a benzene ring for the further reaction. But what is happening? A side reaction is happening. AlCl3 is looking for the electron. Oxygen also have a lone pairs on it. So sometimes aluminium is directly attacking on oxygen, due to which between them a complex compound is generated. Obviously, when oxygen will deliver lone pair to the aluminium, between aluminium and oxygen, a vacant coordinate bond will generate, this one, in which, because one electron, oxygen will completely transfer toward aluminium, so negative charge will come on aluminium, and because it is losing one electron completely toward aluminium, so positive charge will come on it, and one electron as it is on it, this one, this compound will generate there. And let me tell you the color of this compound. This compound can be yellow to deep red or violet color compound. This is the problem. So because of this side reaction, our main reaction is little bit suppressed. What was the main reaction? This was the main reaction. AlCl3 should attack on Cl, CS3 positive should generate, which should attack on benzene ring for the generation of orthocresol or paracresol. But look what AlCl3 and our oxygen is doing. They are showing a side reaction. So if once this is generated, this cannot be generated. Cresols cannot be generated. That's why cresols amount is very, very less, whether it is ortho or para. This is the problem. So sometime board can ask this question, why there is a low yield of cresols in a freidel alkylation of phenol? The answer is because AlCl3 with a vacant orbital is going to attack on lone pair of oxygen. That's why AlCl3 can't perform its main action, which we were considering. This is the reason. That's it. This is the end of a freidel alkylation. Now, next video, we will have a next electrophilic substitution reaction of phenol. Thank you very much for watching the video.